All right. These three go together and they are a challenging set of problems. So we're going to tackle them in turn. There's a big idea going on here. And the big idea is that there are limits to what an angle can be on the low and the high end. The low end, an angle always has to be greater than zero. And I'm not going to discuss the algebra 2 and above ideas of angles that can be negative, angles that can be whatever. Okay, this is just for our purposes. You can't have an angle that measures less than zero in a triangle, and it can't equal 180 or more. In a triangle, there's only 180 degrees to be distributed between the three angles, and none of them can be zero. They all have to have some positive measure, which means no angle can be equal to 180 degrees on its own or larger. It's got to be less than 180. Now, we know that the way that hinge theorem works, um, this short side, I'm sorry, this shared side is equal. These two angles are equal. And so we're dealing with the hinge theorem where if we have two sides that we know are congruent on both triangles, then we can compare the angles by saying whatever is the smaller angle is across from the smaller side. And since 22 is smaller than 30, then 2x must be less than 54. So we'll write that as an inequality. So then there's this other fact about the end limits, which is that that angle, it's smaller than 54, but we know that because it's an angle, it's got to be greater than 0. So that's what we end up with for our lower and upper limits. And then, of course, how do you solve this? You divide everything by 2. And what you get as a result is x is between 0 and 27, but not including them. Okay? So 0 is less than x, which is less than 27. Okay, that's the first one. And you've got to, again, if there's some, the problem sets up some limit on the values, then that's great. But there's always the limit of it can't be, the angle can't be less than 0, or it can't be, it's got to be greater than 0, and it's got to be less than 180. So let's look at this next one. This next one is very similar. And we have 32 and 20, which is smaller. Well, 20 is smaller. So since 20 is smaller, that means that 48 is the lower limit of whatever we're dealing with. So we say our angle that we're looking at over here, 4x plus 8, since it's across from a bigger side, it's got to be greater than that 48. Now, what's the upper limit? 180. Can't be, it's got to be less than 180 because all angles in a triangle have to be less than 180 no matter what. So what do we do here then? Change of color. Let's subtract 8. We're going to solve for x. And in this particular case, you only see the variable appearing in one place, and the rest are just numbers. So we can then manipulate those numbers as we need to. 4x, 176. Okay? And now what do we do? We need to divide by 4. And you should normally rewrite the whole equation and divide by 4 on the next line to leave this what it was, but I'm running out of space, so I just say divided by 4, divided by 4, divided by 4. And what do we get as a result? We get 10 is less than x, which is less than 43. So x can be any number between 10 and 43, but not including them. All right, pretty good. This last one is a challenge. One of the reasons it's a challenge is because we have the variable in two parts of it. So we can't really set up a complicated inequality like we can up here. 0 is less than 2x is less than 54, because if we're then trying to, well, I'll show you, but if we tried to subtract a certain amount of x from one place to be able to get them all together, you would end up where there was none, you would end up with a negative amount of them, and that just won't work out. So we need to do this in pieces. And by the way, just looking up top for a second, you could solve this in two pieces. This one you could say 0 is less than 2x, and you could also say 2x is less than 54. You could do it in two parts and get there's 0 is less than x, and here x is less than 27, and you could still then put them together to say x is between 0 and 27, right? So you could do it in parts, and that's what we're going to do down here on the bottom because you need to. So we know that if we're looking at our opposite sides, we know that 14 is smaller than 18. We're dealing with two angles that are the included angle between sides we know are congruent on both triangles. So this is where the hinge theorem applies. So we know that 14 is smaller than 18, so this amount has to be less than that amount. So let's set it up. You've got 6x plus 20 is less than 10x. And if we subtract 6x from both sides, we get 20 is less than 4x. Dividing both sides by 4, we get this. That's one piece that we need. Okay? Let's continue on. We also know that which angle is the bigger angle? Well, 10x has the bigger angle, right? That's across on the bigger side. So we know that there's nothing limiting its upper end, this upper end. We know that this is limited here by that, but this doesn't have an upper end limit to it, and we need to then place one on it. So let's do it. We essentially say, I'm going to do it up here because I've got some space for it. We essentially say that angle of 10x has to be less than 180. And when we divide both sides by 10, we say x has to be less than 18. Neat. That's another bit of this, okay? And now there's just one more thing we've got to check to make sure about, and it's this. This angle we know is the smaller one, so we've got to say, we already know a lower end of x. It says x has to be greater than 5. Okay, let's check this and just make sure that that doesn't eliminate some of the numbers that we think are allowed from this. Okay, so we take 6x plus 20, and we say that's got to be greater than 0 because it's the smaller angle, and we want to know what's limiting it. So we say minus 20, and we get 6x equals negative 20, and dividing by 6, you get x, I'm sorry, I said equals, and I should not have put equals. Sorry about that, like that. And then when you divide both sides by 6 and simplify, you get x has to be greater than negative 10 thirds. That's a 6 right there. Oh my gosh, terrible. Okay, so x has to be greater than negative 10 thirds, but it also has to be greater than 5 from this. So it doesn't matter that it's got to be greater than negative 10 thirds. It also has to be greater than 5, and that's more limiting, and so we got to stick with the most limiting part of what it says. And so what it appears here then is we've got x has to be greater than 5, and from over here it's got to be less than 18, and that becomes our answer.